Carson from your 4th period math class. We're learning section 3.5, and we're going to learn how to divide fractions and mixed numbers. And you're just coming into the middle part of our discussion on the front page, where we're talking about reciprocals. And so one thing I want you guys to focus on is, you know, what's true about multiplying a number times its reciprocal is you always get 1. You always get 1 when you multiply 2 numbers together that are reciprocals of each other. And so I was trying to show you 1/2 times 2 over 1. Look what happens. That's 2 over 2, which is 1. And that's what happens every time. 5 over 2 times 2 over 5. That's 10 over 10, which is 1. So I just wanted to show you guys that that's always truth. That is truth in math, is that I have a number, I multiply it to its reciprocal. I don't even have to think about it. I know the answer is 1. I just know that's what I'm always going to get. So why in the world are we learning about reciprocals? Why did I bring that up as the very first thing we're learning when our objective is to divide fractions? Where do reciprocals come into play? What do you think?
Because if you divide, a fraction or is a symbol of division.
It is a symbol of division. I totally agree with you. So we'll table that. Let's see if what AB told us is true about why we're learning about reciprocals. All right, so let's flip to the next page. We'll hold that thought, and let's see if you can see a pattern. This is something I was just trying to kind of challenge your thinking a little bit. And so anytime you divide, and here I put a division problem here for you, 3 divided by 3/4. And I've just created one. And one thing that if you don't remember this, I'm going to reteach it to you. You have to change all division into multiplication. We don't divide. We don't divide fractions. Not technically. We turn them always back into multiplication. So we're going to do that using a process called copy, change, flip. And other teachers may call it something else. It's all the same thing. Okay, you're doing the same thing. Step 1, you're going to copy the first number over again. Step 2, change division to multiplication. And step 3, flip the second number over. Okay, and that's how you change division into multiplication. That's how we do it. Copy the first number, change division multiplication, flip the second fraction over. That's how we do it. So I tried to show you a couple of these. Okay, so here's the one that we just did. 3 divided by 3/4 is the same thing as 3 times 4 over 3. Okay, 2 divided by 2/3 is the same thing as 2 times 3 over 2. 5 divided by 5/7, same thing as 5 times 7 over 5. Okay? So, let me come back to you. How do reciprocals tie in with division of fractions? The copy, change, flip. You're exactly right. Okay? That's exactly right. And which part of it? The reciprocals are which part of copy, change, flip?
Changing. Flip. Right?
Because what are we flipping?
The other number. Right?
Yeah, the fraction, right? Or whatever the other number is. And when we flip the other number over, we call that the reciprocal. Okay? So division is really
Addition.
multiplying
Fraction.
the reciprocal, right? I've seen it. I think my teachers from middle school, that's how they taught it, was just change division by multiplying by the reciprocal. Instead of dividing by that given number, multiply by the reciprocal. So that's another way to think of it. It's another way to think of math. So you can look at it as copy, change, flip. A lot of students like that. Or just plain and simply Multiply by the reciprocal. You like that one better? Let's use that then. Yeah. All right, so we're going to do our first example now. We've got some background information. We're going to do 2/3. I'm going to write it vertically just so that it looks a little bit better to you, okay? I think it'll be a little easier if we write it vertically so you can see how it flips, okay? All right, so the first thing we're going to do, we can't divide, so we're going to copy, change, flip, all right? So 2/3, copy that over again. Change division to multiplication and flip 5/6 to 6/5.
And you can do cross multiplication.
Ooh, which one?
6 and 3.
Ooh, what reduces 6 and 3? 3 divided by 3 is 1. 6. There you go. And now you can multiply straight across the top. What's 2 times 2? 4. And 1 times 5.
Examples or like quick chat?
Yeah, that'd be great. Okay, everybody else, come on. Yeah. Watson's going to come up and do our very first one. You'll have to kind of lean at an angle so your shadow doesn't get in the way. There you go. Whatever works for you is fine. And you don't have to use the stylus. You can use a regular Expo too. And you guys try the rest on your own. Don't wait on Watson. Go ahead and figure it out. Good. Nicely done. Very good. Yeah. You are absolutely right. Absolutely right. Nate, will you come up and do the second one for me? Okay. I need you to show your work, okay?
I really like cross multiplication.
You do like that? Good. Good. Not everybody's comfortable with that.
Can we just do we have to do multiplication?
No. Actually, just let me clear up the actual term for it is cross-canceling. Cross multiplication is something we do with proportions. So I don't want to confuse you. So I'm not ever going to call it cross multiplication. I will call it cross canceling. You can, that's a strategy. If you want to use it, use it. If you don't, you can always reduce at the end.
Don't you have to find like the...
No, you only have to have common denominators if you're adding or subtracting. So it's not necessary.
Okay, so
here.
do you just tell them multiple?
Yep, multiply straight across the top, straight across the bottom, and you're good to go.
Is that right?
Mm-hmm.
Okay.
Yeah. All right, and so you want to come up through the last one. The last one's a little bit tricky because the first number is not a fraction, but can you make it a fraction? Can you make the number 14 an actual fraction? If so, what would you put it over? 1. Exactly. You got it. Good.
Wait, I have a question.
Yeah. Good. It's actually going to work out to be a whole number.
Okay.
Yeah. So when you divide those, you'll see it. 2. So it actually has another 0 there that you have to account for. You're off the page, so it's not going to show up, but that's okay. It would be 20. Right. There you go. Good. Hey, I think you guys have the basic concept here, so really good job. All right, now let's go to example 2, and I wrote you a little hint. You may want to kind of put a little asterisk or underline it or highlight it in your notes. The key to dividing mixed numbers is you've got to change them into what form?
Improper fraction.
Improper fraction form.
Can you do copy?
And then you can do copy, change, flip. You got it. You nailed it, man. All right, so let's take a look at our situation. You have a space of 9.5 inches on a poster for a row of photos. Each photo is 2 3/4 inches wide. How many photos can you fit? This is a division problem, and I want somebody to tell me why. Watson, do you know why? Why it's division? explain this. So when we, yeah, because you're looking for how many that can fit, okay? Anytime they give you this whole space that you're supposed to fill up, and they're saying, but the only amount that can fit in there is this smaller amount. We want to figure out how many of these smaller increments fit into the bigger one. That's division always. That's always going to be a division situation, okay? So we want to take our 9.5 and we want to divide it into 2 3/4 inch segments. We want to figure out how many of those will fit across that width, okay? Not yet. We're not ready to do copy, change, flip. It's not in the correct form. Yeah, exactly. Yeah, got to do the improper fraction form first. So, David, what's 9.5 as an improper fraction?
That would be 19 second. Did you say second?
Yep. Mm-hmm. And remember, we're not copy changing and flipping just yet. We want to get our fractions set. So we're not ready to do that step. So we're just doing improper fractions. AC, what's 2 3/4 as an improper? 11/4. Okay. Now that they're both in fraction form, now you can copy, change, flip. So Todd, what would that look like?
19 times 11, 4/11.
You got it. Okay. And you know me, I love my cross canceling. It helps me keep my numbers low. So what number reduces 2 and 4? 2. So what's 2 divided by 2?
1.
And 4 divided by 2? What's, let's multiply straight across the top. What's 19 times 2? 30.
19 times 2 is 30.
8. 1 times 11. 11. Now, I need to figure out what that is as a mixed number, first of all. So what is this as a mixed number?
3 and 8 11. 5 11.
I think it's 5/11. I think we only had 5 left over on that one. Okay, so they're telling me what we just figured out was how many photos I can fit. I can fit 3 and 5/11, but is there such thing as having 5/11 of a photo? There's not. So how many whole photos can I fit without overlapping? Only 3. You got it. 3 photos will fit without overlapping. That's the thing. If I wanted it to overlap, then I could say 4, but we don't want it to overlap. We want it to fit inside of that given amount. And so only 3 photos will actually fit. There'll be a little bit of space left over, but that's okay. That's what happens. All right, 3 different people come up and show us. All right, let me get AB, come do the first one. You can use the stylus, sure. Go right ahead. I have to watch out because I write so big and I start running out of space. I write big because I want you guys to see it, but I know that doesn't always work. So. Somebody shut a door and that's why it shook like that. Awesome. It doesn't look like anything can cross cancel, so I don't know. Sometimes the pen does weird stuff like that. There you go.
69.
That's right. 4 times 11. Nice. There you go. Looking good.
Can I do it a little faster?
Yeah.
Okay, and then. Okay.
It works better when it's kind of going right at the board. So. 69 minus 44, what's that, 25?
Yes.
There you go.
It's 125.
Yep, 1 and 25 44ths. That's exactly right. Lovely. It's not like a pencil where we can angle it. We have to go straight at the boards.
Do a big erase.
Big one?
Yeah, so you erase the whole thing.
That's fine. He'll see it on the video. It's fine.
Are we videoing?
Yes, we are.
Hey, Carson.
There you go. Good job. Put your pen back up. You can actually write your answer 1 and 25 44ths there if you want to. You can see that real good. Good. Over 44. Yeah. All right, Anna, you want to come up and try this?
I'm gonna try it.
Okay. Let's see what we can do. Remember, first step, change to improper fraction. Then copy, change, flip, and then you can solve it. Okay? So that's your process. That's your game plan for getting this going.
32, 33, over 8.
33 over 8, that's right.
11, 2.
11 over 2, that's right. Okay, now you're ready to copy, change, flip.
So, 2, 11.
Yep.
I need to erase it.
I'm just doing that space over there. We can erase later. You can actually cross cancel both diagonals.
You can?
Yes, the 2 and the 8 reduce, and 11 and 33.
4.
What's that? 2 goes into 2, and 2 goes into 8. Nice. 11 goes into 11. Actually, 33 divided by 11 is just 3. And then 11 divided by 11 is 1. So it looks like you got 3 over 4.
Yeah.
And there's your answer. Now if you'll take the eraser, now that you've got your work there and you know what the answer is, just erase this part and put your answer underneath because we see your work, and it's okay if you're erasing my stuff a little bit. It's no big deal. And then get your pen back. There you go. Beautiful. Lovely. All right, Blair, you want to do the last one for us? Come on now.
Did she get 1, 2?
Oh, she got 3/4.
Oh, I thought you were supposed to turn into mixed number.
If it was an improper fraction, you would.
Oh, yeah, it's 3/4.
Yeah, when it's proper, you don't have to do that. You just leave it just like it is. Okay? Okay. All right, we have to avoid our shadows.
We're going to 57.
Yes, it does. Yes, it does.
It does?
Let's see here. 19? I think it goes 19 times. Yeah, okay. Good, I have verification. Oh, I like how you did that. Very good. Good. Great. Looks great. There you go. Love it. Looks great. 1916. Okay. Yep. And then your mixed number. There you go. Great. No problem. Hey, great job. You guys getting it? What's your 1 and 3/16? 1 and 3/16. Great job. Great job. Let's get to an application problem here. They're letting us do some meal planning. I don't know how many cooks we have out in the audience, but hopefully we have some. No cooks. Oh, sorry. All right. 1 and 3/16, or 19/16. How many 1.5 ounce servings of cereal are in a cereal, not a Creole box, a cereal box that contains 19.5 total ounces? Now, you have your box of cereal, and if we had a measuring cup, they're asking us, if I took out 1.5 ounces out of my box, how many scoops would I have scooped out of my box? Okay? So, remember what we talked about. They gave you the whole amount that's in that box, and they want to know how many of a certain increment, in this case 1.5, how many 1.5 ounce increments are there in the box? This is division, okay? So you're going to take your total. You're going to divide it into 1.5 servings, and let's see how many are actually in the box, okay? So I need to know what 19.5 is as a mix,
39 over 2.
or an improper fraction. 39 over 2.
And then divided by 3 over 2.
No, 38 over 2.
Oh, it is 38?
It's 19 over 2.
What's 2 times 19?
It's 39.
38 plus 1.
Plus 1 is 39.
Okay.
Yeah.
All right, so now we're going to copy, change, flip.
What if you did it the other way? Like I had 1.5 or 19 over.
Okay, you're going to get a really weird answer.
Yeah, I got 113.
Yeah, you're going to get a really super weird answer. You want to take the total amount, that's the total, the big amount, and divide it into the smaller amounts. So you want to flip it. I do not have a cap, I'm sorry. Now I love cross canceling, and so my 2's are going to cancel each other out. And believe it or not, 3 goes into 39 13 times. And so I'm going to end up with 13 over 1, which is 13. So if I had my cereal box and I wanted to know how many servings, how many 1.5 ounce servings would I scoop out of my box, I would scoop out 13 times.
About.
Exactly 13.
No, what, if you want to use exact measure.
I will if I'm using a measuring device.
Yeah, but that's.
All right, so let's try this one on the bottom. You got a can of iced tea that holds 12 fluid ounces. So one can is 12 fluid ounces. Now a 2-liter bottle, is a 2-liter bottle bigger or smaller than a can?
Bigger.
It's bigger. Now it holds 67 3/5 fluid ounces. How many cans of iced tea will you need to fill a 2-liter bottle? So, in other words, if I had an empty 2-liter bottle, how many times would I empty my 12-ounce can into it and fill it up? That's what I'm asking, okay? So what's the big total amount that we want to divide into smaller sections? So look for the big total amount that's on your paper here.
12. The 12.
12, no,
Oh.
67 3/5 ounces. And we want to divide that, and we want to figure out how many 12 fluid ounce increments there are. Okay? And why do you think I put 12 as 12 over 1?
Because that's what you do.
Yep.
Because it's the whole number.
Will it be easier to flip when it's already in fraction form? Yeah, that's why I did that. Okay, so off the side of your paper, I need you to multiply 5 times 67, then add 3.
335.
Yeah, I got 338.
Yeah. Can 12 hold or 338?
I don't think so. But you have to come up even numbers, right?
Yeah.
12 can go to 338, right? And that's
I don't know if 12 can, but they're both even, so at the very least 2 will reduce both of them. And now I'm going to copy, change, and flip. Okay. Now you can, if you want to cross cancel a little bit, you can. They're both even, so you could at the very least figure out how many times 2 goes into 338. You could do that.
Can 12 go into 98?
If you want to, you could try 12 into 338 and see if it goes evenly. So 12 into 118. I don't think 12 goes into 118, so I'm not sure that's going to work.
Wait, no, it's not. No, it's probably,
What's that? Did I do some math wrong somewhere?
Yes, you did not, it's not.
9, it's 9.
What is
3
mine?
minus 24.
Oh, yeah.
33 minus, oh yes.
Yeah.
Okay, so 9,
98.
98, 12 and a 98. I know 12 goes into 96
yes, 8 times.
8 times, so it's not going to go even. So 12's not going to work. That's fine, it doesn't have to. I know 2 goes into 3 1 time. 2 goes into 13 6 times, and 2 goes into 18 9 times. So I do know that I could reduce 338 down to 169, and 12 I can reduce down to 6. And that's reducing by 2 on each of those numbers. I don't know, it may not matter to you. You may go, I don't care if it's big or not. And then we'll end up with 169 over 30.
And that could be reduced. No?
Yeah, I think 3 can go into it, but you know, we'll go ahead and do our mixed numbers. So I'm gonna go ahead and just do the basic division here. 30 goes into, I know 169 at least 5 times. 5 times 30 is 150, and then so it looks like 5 and 19 30ths. So how many cans of iced tea will you need to fill a 2-liter bottle?
5.
Well, should I leave it at 5 or bump it up to 6?
6.
Yeah, 6 will safely fill it up. 5, it'll almost be filled, but not quite. So I will need 6 cans. And I won't use all 6. I'll use 5 and a portion of another one. But I'll need 6 to fill it up 6 times. Okay? So how did we do today? Pretty good? Yeah?
That was pretty easy.
Good. Awesome.